But some of you, if we redo this, might prefer, instead of using 334, you might want to actually know what is the angle inside of there as it stands. And so the way it's drawn, that is. And so we draw our unit circle again, and we know that we have 270 down here, and we're saying that right here is 334. So this little piece in the middle right here is going to be 334 minus 270, which gives us an angle of 64 degrees. Okay, and so that means that 64 degrees goes right here. 64 degrees goes right there. Okay, now if it's 64 and this is our opposite and this is our adjacent, then we can do the problem like we were doing earlier, where we look at our trig functions, SO, CA, and TOA, and in this case it's just going to be sine and cosine. We rearrange the three-variable equation, multiply both sides by the hypotenuse. You can go back and see that on the first one that we did, and f2 sub y is very simply going to be cosine of 64, since that's adjacent, times the magnitude, which is 11.2. Okay, and that's going to equal 4.909 newtons, whereas before it was negative. Now it's positive. Well, it's positive. We didn't write negative because we already know the direction. We drew the direction, so we understand, we're smart enough to know it's in a downward direction. So 4.909, you could think of it as down instead of negative. Okay? In the previous slide, the answer was negative here. Okay? And in this slide, we're just going to say down. It's the same thing. Just depends on which angle you use. If you're going to use counterclockwise from east, or if you want to actually find the angle inside the triangle. Okay? So there's two ways that you can do it, and I'll accept either way. It doesn't matter to me. Okay, so now we're going to do sine of 64 times the hypotenuse, which is 11.2, and that's going to give us a component of 10.0665 newtons. Okay, so there is our x and y components for that triangle. Okay, so our next triangle is 205 degrees, so we're going to redraw this triangle by itself so that we're not looking at too much at one time. And then since we're dealing with an angle larger than 90, we can just go ahead and put that in. Sine of 205 times the magnitude of 11.3. Okay, that equals, let's see, sorry, that equals negative 4.776. I'm going to round. And then cosine of 205 degrees times 11.3 equals negative 10.24. Okay? So I look at these, and I got a negative 4.776 and a negative 10.24. Well, sine should be opposite, and opposite is going to be over here. So F3 should equal negative 4.776 newtons, and the adjacent angle, which is cosine, is going to be negative 10.24. 10.24 newtons. I didn't round that quite as far. And we can also look at it and see that one of the numbers is larger than the other because one of these vectors, one of the components is longer than the other. Notice that this is much longer, so it should have a greater magnitude. So make sure you don't get those mixed up. Okay, so now that we got our two components for our last one. But just in case you wanted to find the angle in here and not use the 205, which is okay, then what you're going to do is we're going to draw our unit circle. So we're 0, 90, and this is just for a reference, okay? You may not need to do this, and 270. And we're saying that this is 205, right? We're saying that this is 205. If this is an angle of 205 degrees, and this right here is 180, then 205 minus 180 is going to give us that angle inside of that triangle, which is 25 degrees. So this is actually 25 degrees. We're going to write 25 degrees in there, okay? So if we redo our SOHCAHTOA and we want to find f3x, which is cosine, whoops, it's hard to write on the tablet. Then f3 sub x is going to be cosine of 25 degrees times 11.3, which is going to be 10.24, and f3 sub y is going to be sine of 25 times 11.3, and that's going to equal 4.776. So both of these came out to be positive because, again, we know the direction. Both of these are down. I'm sorry, f3x is not down. f3x is to the left, and f3y is down. So both of those would be also considered negative, like we got in this particular answer, okay? Okay, so now that we've done each of those, we've actually worked out all of the components. So we have a total of 6 components. We got the first 2 on F1, and then we've got the next 2 on F2. We did it 2 ways. And we got the last 2 on F3, and we did that one 2 different ways. So we got a total of 6 vectors. So what I recommend is that we make a table. So I'm going to make a table. So we got F1, F2, F3. And we've got both an X and a Y component. And you can do this the same way on your paper during a test. Just a freehand table. Doesn't have to be perfect. You just want to be kind of neat and organized with your data. But we don't have to be particularly, you don't have to get a straight edge or anything. And with F1, we got 9.548. Notice I'm carrying my answer out 2 or 3 places past the decimal. I'll round later. And I can also think of this as east, or to the right, or positive. Okay, I can think of that as positive or east. And for the y component, it's 10.239, and we can think of that as a positive number, or we can think of that as north. Either way. All right, on F2, we got a 10.24 newtons, and this is newtons also. 10.24 newtons, and we can think of that as negative or west. And this one's negative 4.776. I've rounded that a little bit, and we can think of that as, well, I wrote negative already, but negative or south. And the last one, F3, has a horizontal component, which is 10.0665, and we can think of that as positive or east. And last one is 4.909, and we can think of that as negative or south. Okay, so now I'm going to put these together. So I've got a positive, a negative, and a negative, or you can think of it as a north, a south, and a south. So what you want to do is put your 2 south together, or negatives together, and then we want to take the difference with the north. And over here, we got a positive, we got another positive down here, and we got a negative one in the middle, or you can think of it as we got an east at the top east on the bottom and a west in the middle. So we want to add up our two east and then take the difference from the west. So you want to add all those up, so you should get 9.3745 for your total horizontal component. And for the vertical components, we're going to get a total of 0.5544, and that's in newtons. Okay, so now we got a total x and a total y. Okay, we had three vectors at an angle. We broke all three of them up into their x and y components. Then we added all the x's together and got 9.3745, and we added all the y's together and got 0.5544. Now what are we going to do with those? We're going to make a triangle. Okay, we're going to make a triangle with these. So what I'm going to do is my total x came out to be positive. So positive should mean east. So I'm going to draw a line east. It's not to scale, I'm just sketching it. And then using head-tail method, wherever I left off, I'm going to draw the vertical component, which is 0.554, which is positive, which can also be considered north. And so this one's 9.3745. This is 0.5544 newtons. Okay, so now this is my resultant. That is my resultant. Right here, this is the angle of that resultant. So how do we find the resultant, the magnitude of the resultant? Well, what I'm going to do is use the Pythagorean theorem. Okay, and with the Pythagorean theorem, I know that this resultant, we'll call it r squared equals the side, which is x. We'll call this x squared, which is down here, 9.3745, plus the y component, total y component, which is y squared. So r squared equals y squared plus x squared, and we're going to take the square root of all of that. And so my r component equals square root of my total x component, which is 9.3745 squared plus 0.5544 newtons squared. And keeps changing colors here. And we're going to do that little work there, and we should get a total of 9.391 newtons. Should be your total when you work that out. Okay? Now, how about the angle? Let's change it to red. Now the angle, if we, now we know all three sides, but I'm going to use the two x and y components. Okay? I can use any trig function, sine, cosine, or tangent. I'm going to use tangent because we haven't used that yet. So tangent of the angle equals opposite over adjacent, right? And what we're looking for is the tangent, is the theta. And so here's the trick to getting rid of a trig function. If you want to get rid of a trig function and solve for theta, you do not divide by tan. That doesn't make sense to divide by tan because tan is not a variable. Tan is a trig function. So what we're going to do to get rid of it is we're going to do arctan, or tan inverse, times tan. And whatever you do to one side, you have to do to the other. Okay? So tan inverse of tan goes away, becomes 1. And tan inverse of opposite over adjacent should equal our theta. So theta now is going to equal tan, I'm going to rewrite it this way, tan inverse, and if you put this in a calculator, a parentheses will open, and your opposite, which is right here, this is opposite, this is adjacent. Opposite's going to be 0.5544 divided by adjacent 9.3745, and that should equal your angle, which is 3.38 newtons. Okay?